In this video, we're going to discover where the formula for the volume of a sphere comes from. In a previous video, we saw that it took two cones to fill a sphere with the same radius. So we'll now go back to recall the volume of a cylinder. And if we remember, the area of the base is pi r squared, since the area of a circle is pi r squared, and we can get the volume of that cylinder by multiplying by the height. We later learned that to get the volume of a cone, we would take the volume of the cylinder with the same height and same radius and simply divide it by 3. As we saw in the experiment, it took two cones to fill up a sphere with the same radius. It's important to note that that would mean the height of the two cones would be the same as the height of the sphere, and the radius of the two cones would be also the same as the radius from the sphere. So what this really means is that we could find the volume of one of these cones and simply add another volume of a second cone to determine the volume of a sphere. But this isn't necessarily the most efficient way. If we analyze the relationship between the radius of the cones and the height of the sphere, we'll see that 2 radii is equal to 1 height of the cone and 1 height of the sphere. So rather than calling the height of the cone h, we could essentially replace h with r plus r, or 2 times r. Following mathematical convention, we'll bring the coefficient of 2 to the front of the term. And simplifying r squared times r, we get r cubed. Simplifying further, we'll notice that we have two fractions, 2/3 pi r cubed plus another 2/3 pi r cubed. So let's write this a little differently to make it look a little easier to work with. While we can likely see that 2/3 plus 2/3 is 4/3, let's put them together to make this a little more obvious. Since we have a common denominator of 3, we could put our 2 plus 2 in the same numerator over one denominator of 3 to get 4/3 pi r cubed, which can also be written as 4 pi r cubed over 3.